Hello everyone, I'm Arpita KB. I am second year Computer Science and Engineering student, PES Institute of Technology and Management, Shimoga. Today I am going to explain about mission instructions and instruction sequencing. In this session, I am going to explain about what is meant by mission instructions and instruction sequencing, which is introduction. Then the motto of this session. Next is prerequisites. Then mission instruction and instruction sequencing. Now, what is meant by mission instruction? Mission instructions are mission code programs or commands. Mission code or mission language refers to a computer programming language consists of string of zeros and ones, that is binary code. Next, what is meant by instruction sequencing? Instruction sequencing is the order in which instruction execution is carried. From this session, you will get to know about mission instruction, its type and execution, and instruction sequencing. Before this, you have to know about memory, register, and then the connection between processor and memory. Now let's move on to mission instruction. As computer only understands the code in binary form, these mission instructions are directly executed without any conversion. A mission instruction consists of several bytes of memory that tells the processor to perform one memory operation. The processor looks at mission instruction in the system's main memory one after the other and performs one mission operation for each mission instruction. The collection of mission instructions in main memory is called mission language program. The general format of mission instruction is label, mnemonic, operand, operand, semicolon, comments. Here brackets indicate that a field is optional. Then label is an identifier that assigns the address of the first byte of instruction. Label is followed by colon. It is compulsory to include the space, at least one space, otherwise it may lead to any other uncertainty. Then mnemonics, it is the short form. Then operand, operand, and then it is followed by commands. Here I gave example of move R1, R2. Here in this example, mnemonic is move operand, operand are R1, R2. The next topic is elements of mission instruction. The elements of mission instruction are operation code, which is also called as opcode, then source operand and destination operand. Opcode means it specifies the operation to be performed. Source operand means it contains either data or address to be delivered. Destination operand, it stores the final value. For example, move R1, R2. Here move is operation code, R1 is source operand, R2 is destination operand. Now let's move on to types. First type is data transfer instructions. These instructions transfer the data. For example, move in out, LEA, LDS, LES, push, pop, exchange, XLAT. I have represented this example in assembly language. Move is used to move byte or word. In and out are used to input or output the byte or word from the port. LEA is load effective address. It is same as move instruction, but rather than loading the content of specific address, it loads the address itself. LDS, load DS register. It is used to load DS register and other provided register from the memory. LES, load ES register. It is used to load ES register and other provided register from the memory. Push and pop. These are the operations of stack. Stack is the arrangement of elements in the memory in the form of first in last out. It means when we place an element one above the other, the first to remove is the last element. Push operation is used to insert the elements on the top of another element. Pop operation is used to remove lastmost element. Exchange. It is used to exchange byte or word. XLAT. It is used to transfer byte using lookup table. Lookup table is an array that replaces runtime computation in a simpler way. Next instruction type is arithmetic instruction. Example, add, subtract. It is used to add or subtract byte or word. ADC and SBB. It is used to add byte or word and carry, or subtract byte or word and borrow. Increment or decrement. It is used to increment or decrement byte or word. Negation. It negates the byte or word. Compare. It is used to compare bytes or words. Next one is multiply or divide. Integer multiply or integer divide. These are used to multiply, divide, integer multiply or integer divide byte or word. CBW, CWD. It is used to convert byte to word or word to double word. Next type of instruction is logic instruction. Example, NOT. It performs logical NOT of byte or word. Logical NOT is used to get negation of input. AND. It performs logical AND of byte or word. Logical AND is used to get 1 if both the input are 1. Or here the output will be 0 if both the inputs are 0. XOR. In this, output will be 1 if either of the input are 1. Test. It is used to test byte or word. Logical shift left. It is used to shift the 1 byte to left. Logical shift right. It is used to shift 1 bit to right. Next one is arithmetic shift left, arithmetic shift right. It is used to shift arithmetic shift left or right byte or word. Arithmetic shift is also a type of shift, but the difference between logical shift and arithmetic shift is logical shift treats the number as a bunch of bits, whereas arithmetic shift treats the number as a signed integer. rotate left or rotate right. Rotate left or rotate right is used to rotate byte or word to left or right. Fourth type of instruction is string manipulation instruction. It loads, move, store, compare and scan for byte or memory of string. Example, move string. It move byte or word string. Move string byte. Move string word. Compare string. It is used to compare byte or word string. SCASS, it is used to compare byte or word string to A or AX. Load string, store string. Load string, store string. It is used to load and store byte or word string. Next one is control transfer instruction. Example, jump. It is unconditional jump. It includes loop transfer and subroutine and interrupts instruction. JNZ. It jump till the counter value decreases to 0. Fifth type of instruction is loop control instruction. Example, loop. It is unconditional loop, count in CX, short jump to target address. Loop NE or loop NZ, it is used if loop is not equal means not 0, count in CZ, short jump to target address. JCZX means jump if CZ equal to 0. It is used to skip code in loop. Call return. It is used to call return from the procedure. INT or INTO, these are used to represent software interrupt and interrupt if overflow. Last type of instruction is processor control instruction. These are used in flag manipulation. Example, STC, CLC, CMC. These are set, clear, complement, carry flag. STD, CLD. These are set, clear, direction map. STI, CLI. These are set, clear, interrupt, enable flag. Push F, pop F. Push flag onto stack or pop flag off stack. Next topic is instruction cycle. First, understand what is meant by instruction cycle. It is the time required by the CPU to execute a single instruction. The execution of program starts when the operating system loads the copy of program instruction to main memory. There will be a set of machine instruction in main memory. So, it can be directly executed by CPU. Instruction cycle execution starts by fetching machine instruction by CPU from memory one after the other. After the execution, CPU stores the result back to main memory. Machine cycle refers to execution of part of an instruction. So we can say that machine cycle is a part of instruction cycle. Number of machine cycle depends upon CPU architecture. For example, in 8085 processor, there are 6 mission cycles. Now let's take an example flowchart. In this flowchart, T states refers to clock pulse. Instruction cycle starts by fetch operation. Sequence counter initialized to 0 at T0. Content of the PC assigned to address register AR. Always PC contains the address of next instruction that has to be executed. In T1, the instruction is fetched from main memory and move that instruction to IR, and at that time PC is incremented to 1. Next is decode cycle. In this cycle, control unit of CPU decodes the instruction placed into the IR during fetch operation. CPU decodes the instruction as instruction format. Instruction format means it is a layout of bits of an instruction. It is made up of combination of opcode, addressing mode, and address or operand. In 16-bit, 0 to 11 bits are assigned to address or operand, 12 to 14 for opcode, 15th for addressing mode. Control unit decodes as per the opcode specified in 12 to 14 bits. Control unit decides the type of instruction, whether it is register instruction or input-output instruction or memory reference instruction. The type of instruction is decided by D7. 3-bit of opcode can have 8 values, D0, D1, D2 till D7. Next step is to decide addressing mode and clock pulse T3. If the value of D7 is equal to 1 and I is equal to 0, then the type of instruction is register reference type. Else, if the value of D7 is equal to 1 and I is equal to 1, then the instruction type is input-output instruction. Else, the value of D7 is equal to 0, then type of instruction is memory reference type. Decode cycle ends after deciding the type of instruction. Execution cycle. In this cycle, processor performs desired operation on the fetched data placed in the accumulator register. For input-output instruction and register reference instruction, processor performs desired operation and sequence counter again initialized to 0. For memory reference type, 5th bit of addressing mode decides whether execution is direct or indirect. In case of direct referencing, I is equal to 0, the processor executes desired operation and sequence counter again initialized to 0. For indirect referencing, I is equal to 1 and the effective address of the operand is loaded, and then processor executes desired operation and sequence counter again initialized to 0. After the execution cycle, it halts to check the interrupts. The value is stored in RAM. Next topic is interrupts. There are 3 types of interrupts: external interrupts, internal interrupts, software interrupts. External interrupts are from input-output devices or from timing device. Internal interrupts are from illegal or erroneous use of instruction or data. Software interrupts are by executing an instruction. Next topic is instruction sequencing. General meaning of sequence is arranged in a particular order. Here I gave a daily life example for sequencing, that is hand washing. As you can see here, first we turn on water tap, then wet our hands, next we soap our hands, then rub hands, rinse hands with water, then turn off water, at last dry hands with towel. Like this, instruction also execute in a sequence. Operations performed by instruction sequencing are data transfer between the memory and the processor register, arithmetic and logical operations on data, program sequencing, and input-output transfer. Next one is rules. There is no relation between fetch or read, execute or update of previous instruction. Read of an instruction occurs after update of every instruction within any preceding instruction group. The processor may execute any subset of instruction group concurrently or serially and may reorder instructions within an instruction group. Now we will take an example program. Here the example is to add two numbers and place the result in another variable. Here A, B, C are data for this program and the execution starts at the address I and there are three instruction program segments. They are move A, R0, add B, R0, move R, C. At the beginning, the content of A is transferred to R0. Then B and R0 are added. Then the result of addition of these two will be stored in R0 and the content of R0 is transferred to C. Like this, we can do execution for read and character also. For this presentation, I referred Computer Organization by Carl Hamacher, articles from www.greeksforgreeks.organization, www.gradeup.com, www.cs.nmsu.education. In this video, I explained the most basic things that comes under these two topics, machine instruction and instruction sequencing. I hope you enjoyed this video. Thank you.